All right, welcome ladies and gentlemen to week number 41 open Q&A. Thank you so much for joining me. My name is Mr. McLogan and I am here to answer your questions as well as kind of give you a little bit of talking about calculus here to kind of get started. That is something that is obviously something I'm very much involved in, teaching AP calculus for a couple years at my high school, and I've been teaching pre-calculus, for the last 10 years. But it's just definitely been some things that I have been thinking about. So I want to kind of give you my kind of thoughts on kind of calculus and the kind of forward direction as education. And then I will get through all of these questions that you guys have submitted. So if you are new to this channel or new to to my live streams, and you would like to submit a question yourself, then you can go ahead and click down below in the description. I do have a link to a Google form where I take in your questions every single week and I answer them every Sunday night at 9 p.m. Eastern Standard Time. So that is the process. You are able to upload. You can see, like, I had students upload some pictures. That is usually my preferred method. So therefore I can just copy and paste the problem. There are some questions where students just had general questions for me. And that is always acceptable as well. But I always ask just to be very specific on what it is you need help with. I did get all the way caught up. There's a couple questions I wanted to check in on that I didn't add for this week. But, a lot of times there's questions I just have to delete them because either I don't know what the student is asking or they're not very clear and everything like that. So, hey, Joshua. Hey, Frankie. Hey, Justin, amateur animator. Pino, Emmanuel, Ogwan, Jason Vu. Picor, Ghost Rider, Nolan. Well, thank you very much, guys, for joining in. I really do appreciate you coming. And I see, Frankie, that we are going to talk about writing the equation. Well, hello, Melinda. You finally made it to a stream. Good to have you on, finally. We should probably be adding these to the Discord as well, too, just so people always are aware that I'm going live. Even though, I always try to make these Stripe streams I always post them on my community board in YouTube, but I know that doesn't get shown to everybody. Actually, hold on a second. I can't believe it. I actually forgot to post this. No, did I forget? I don't know. This weekend was crazy. I was recording for my pre-calculus course, and I was trying to do my trigonometry unit. So, but I got to recording like half of the trigonometry unit, and then I just got so exhausted, and I couldn't do it. And I tried to do some recording today, and I was just too tired. And so I'm about halfway through my recording of trigonometry, and so I'm making all those videos for my students in the classroom as well as online to help them with the trigonometry section, which we haven't started yet in my class. I'm teaching pre-calculus again, this year. We haven't started that yet, but I always like to make those videos in advance, so therefore I can just teach live, and then as the students need them, they need that. But I wasn't planning on going into that, but I do have some plans. If you are taking pre-calculus, I am going to plan on bringing in some things for semester exams. I do have some trainings and stuff like that I am hoping to get out to you guys here very shortly. So definitely keep posted for that. I will let you guys know about that. And also thank you so much for your channel members. I do have some updated videos that I need to get to you guys, and I will be doing that as well as doing my stream. We'll plan on doing that coming up. So I will be posting that for you guys, for all you channel members. Thank you so much for supporting my channel. I greatly appreciate it. All right, so now let's talk about calculus. And should everybody really be taking calculus? And the reason why I kind of brought this up is I've been reading a lot of articles, talking about how this COVID pandemic, is how it really kind of adjusted our thought process. And one thing I've always had a problem with is, there's a couple of instances that I always bring up to me. And one of them is, a lot of times when, I'll tell people what I'm doing, and I'm like, oh, I teach pre-calculus or I teach calculus. And so it's like, oh, you must be like, you're so smart, and like, and I'm like, okay, well, yes, I do know there's a lot of like barriers, a lot of jumps. Like, yes, you do have to have you have to do a lot of, calculus is not for everybody, right? So I do know there is a select group from that side, but I don't consider myself any better or any smarter than anybody that did not take calculus. But it's just kind of funny how we have calculus is just kind of on this pedestal. And obviously calculus is just the in reality of the world of mathematics, I mean, it's just the beginning of, really the world of your, mathematical understanding. But, it's still been something that's just going to be, held on this pedestal that if you can take it, or if you have taken it, or if you did well, or if you teach it, that you are, that you have this, some sort of like gift, that other people do not possess. And I have a kind of a problem with that. In the reality, because I think it sets students up for, that they have to, if they are going to be competitive, or if they are going to consider themselves smart, that they have to take, calculus, and they have to do well in it. And the problem that comes up with that is, obviously as a teacher of pre-calculus, I have a lot of students that have this mindset, and their only concern in my class is getting the best grade, or even in calculus, like their only concern was getting the best grade in calculus. Had nothing to do with understanding of the material or any, knowing what was going on. It was kind of like more that they, we are using calculus, or we're using our mathematics curriculum to really kind of organize, compare, and rank our students. And really that ranking, obviously it serves its purpose of, being able to distribute students to different colleges and blah, blah, blah. But outside of, that, it's like, I don't think there's any correlation of the, that students that have taken calculus in their life, or have done well, or have a mathematics degree are any off better, smarter, happier, in their life. And obviously I think taking calculus is a very important subject, that we need people to do calculus, and we need people to be excellent in calculus. But there's also this whole idea of, also like creating students that have this mathematical mind, and obviously we need that calculus component. But in the same respect, it's, we still we train all of these students to go towards that calculus path, when in reality, like a lot of the things that we still teach in far as in calculus and, up to that point, we don't really need students to be able to do a lot of these mathematical operations. We have these machines and computers now that really can take advantage of a lot of those mundane tasks that we still are drilling down with our students. And I think it would be much better served to, to really realize like what is the most mathematics that students are really going to need. And obviously the students that are going to be taking that calculus path, like let's push them, let's, stretch their mind, and let's encourage them and continue that. But I think this idea of that everybody needs to arrive, like calculus is this pedestal that every student, needs to take. And if you don't take it, then you are not considered, superior compared to those students. I think is a mindset shift that is going to have to change. And I think it is one of those things that is changing, looking at the purpose of education, and why people are going to school and why they're going to college, and, what we really want out of our students in their education. And I think a lot of it is, students do all this because that's just kind of the way we've been programmed, and there's been really no reason for us to change things. But I see students that are just stressed out to the max, and because they don't have the foundations that prepared for my class or for calculus, or to, even just for the grades, they're just so stressed, for trying to compare and compete against all the other students. And when in reality, that might not even be the best path for where they need to. And even if they don't, take that, even if they don't take the calculus, like they can be very successful. I always tell people as well, like I never even took calculus in high school, and I have a mathematics degree, right? And so, I think it's just this idea that we've, a lot of students have been sold this idea that, that you have to take calculus, you have to be successful in calculus before you're even going to get to this school or get this degree. And I think it's just, now we've had this opportunity to really sit back and reflect on really what is the purpose of taking some of the classes we're taking, right? We've just been kind of going down the same path, doing the same old things. But now I think it's a really opportunity time to say, like, what are we teaching our students and why are we teaching them this stuff? And really we need to be able to create a pipeline for the students to, follow, that they're going to be able to serve our communities and, serve their own educational minds. And I'm not sure that the pipeline for calculus is going to be right for everybody. And I think rather than pushing everybody to this calculus curriculum that a lot of our Algebra 1, Algebra 2, geometry is designed for, that we kind of look for other opportunities to best instruct our students and, or at least to provide them a mathematical education, So those are some of the things I thought in my mind. I wanted to talk with you guys, or I wanted to express all of that to you. So I greatly appreciate you guys being my sounding board for you on that. So, but thank you so much for that, because I was some things I just wanted to really say. So either way, I see Nathaniel and Addie and Zakaru and Sammy and Trissy and Melinda back on. She said homework is not a grade, so I put it off. I'm getting a good grade. But yeah, and I don't know. I mean, I think there's a lot that comes with understanding mathematics within time. It's not something that I think that's one of the other problems that I see with students is, they feel like so rushed to have to go through everything. And I mean, and first of all, like I have no problem with students learning calculus. One of the things I mentioned in my email today, calculus was the subject that that was the turning point which made me decide that I wanted to study mathematics. And the reason being is because calculus was that first subject that really connected the dots for me. It was really like, oh, now I realize why all those things that I've been learning up to that point, was meaningful, and I'm bringing them together and I'm actually using them. And then also I can apply this stuff into, real life scenarios, and calculus was that course that really helped me get interested in mathematics, because, up to that point, I really didn't care for much of mathematics. I kind of enjoyed it, but it really wasn't my cup of tea, to say. Like, I wasn't great at it. I didn't fully, love the content, but it wasn't really until I got to calculus, I was like, oh, I'm actually really kind of starting to like this. Like, I want to learn more. But that was something, it took some time. And I think that everybody right now, or at least a lot of students that I'm seeing, is they're not worried about time. They're worried about, getting this kind of award for going to this calculus path so they can get ranked higher. So therefore they can compare against other students. But that's it, and I see this problem with, you look at the, students that are going through, like, if you're not, what is the purpose of taking the calculus? Like, not so much to rank. I know that, so you can see that you're better or have higher grades and a better GPA and everything like that. But it's like, we want to make sure students are taking, courses that they are going to be able to apply and use. And obviously there's always going to be those courses, that, we're trying to build a general, just better general education and study for. But I think that there's so many more maths, and this is the thing that really gets to me. There's so many things that we could be teaching our students that would be beneficial to them in mathematics that we are not teaching them. And the problem that I see is I'm trying to, I'm for this year, and this, here's another point that I wanted to make. And I think this is really important, that there's so many things that I'm teaching my students right now, because I'm teaching right now algebra 2, geometry honors, and pre-calculus. And besides the pre-calculus, right? Because pre-calculus, most of those students are planning to take calculus, right? So I have no problem teaching them the mathematics that they need to know for calculus. Like, that is the design. I mean, there are some of the students that are just taking it to, do better in their whatever course they may take calculus later. But those students are typically on that college calculus kind of plan if they're, taking pre-calculus. But there's a lot of students that I'm teaching in my geometry and algebra 2 that are not on the calculus plan. And there's so many problems that, I'm presenting to them and we're going through that. I'm like, these kids, a lot of these kids, they're not taking calculus, and they're stressed out over how to do these problems. They don't have the foundations to do these problems, and I can't make any connections real with them because they're so disconnected from what they know and what they need to know. And it's very frustrating because obviously I have students that, are going to calculus, and you can kind of prepare, they're going to be going into pre-calculus next year and they're going down that route. But then there's just other students that it's like, you just want to teach them the things they need to know, or things that are beneficial, that are cool, or to investigate, to get curiosity out of them. And I feel like there's a lot that is constrained for us teachers because it's still onto this push of getting students through this program with this pedestal of calculus. And that makes me sad in a lot of reasons, because I know there's a lot of students that we've turned off from mathematics because of this push into that calculus route. And so those are some of the things that makes, that upsets me, because I know we're not serving all of our students. Some of the students we're serving that are going into that calculus route, but there's a bigger population that is not going to that calculus route or does not need to go to that calculus route that we are not serving them. I think there's a lot more mathematics that we could be providing to them that's going to be much more beneficial to their education as well as to their life that they can go and use and apply and actually enjoy. And therefore, we might change the tides of people saying, I hate mathematics, or I hated my math class, or, and I'm not good at math and all that kind of stuff. So there we go. That made me feel a lot better. All right, so let's get into some math. Yes, I would say, Janison, stats is one of those big concepts. Stats, some applied mathematics, financial, discrete mathematics. There's just a lot. There's so much more math that we could be teaching our students that I think they would enjoy and be able to apply. All right, doing inference series, super cool stuff. Yeah, and I mean, there's definitely some really, really interesting stuff. And I used to think that I really do wish actually that we could actually propose more students actually into calculus. But I think that's the problem with calculus is I think we have so many hurdles that you have to pass so many hurdles to get to calculus. And I think there's definitely some ways that we could teach more students about calculus and about the calculus concepts without having to force them to understand so many or remember and to apply so many algebraic, concepts. Because in reality, a lot of the students don't need to. It's not like when our parents were around and doing calculus, they needed to be able to do all those mathematical, algebraic, computations. And, we can benefit from a little bit of technology. And I think it's useful for us to be able to still encourage and expose students to the math of calculus without having to force them to go through so many steps like like in previous generations. So, all right, that is off my little soapbox there. I always get it's always kind of funny when I'm talking to people and they always bring up math or not really so much math, but if they bring up education and things to improve and whatever else, I'm like, it depends on how much time you have, because if you really want to have this conversation, we can sit down and I will just talk about it. And because obviously it's something that's very, very passionate for me. So I could just keep on going on. But yes, Mateus, this is really live. And so I am just going at it, just chat. But now I'm going to get into some math. So when I do the math, though, guys, when I do get into the math problems, I do not obviously often check the chat. So if you do have a question, please wait till the end that I have. Again, if you do have a mathematics question that you'd like me to submit, in the description there is my Google form link that you can submit to them. And I probably will not be able to get to any more questions inside the Google form tonight, but you can always submit them and I will cover them every Sunday night at 9 p.m. Eastern Standard Time. And if you're looking for a little bit more immediate feedback, you can always go to the Discord channel and go ahead and submit a question. But I always ask, guys, if you're going to, the Discord channel is more as a community. It's really, I'm not able to answer, many questions. I try to check in a couple times a week, but in reality, guys, the Discord channel is only as strong as the students that are helping each other out with that. So, if you're going in there and posting a question, feel free to answer somebody else's question. There's a lot of questions that are being posted inside the chat. But it's not just one where, you're posting questions and then you're obviously going to get an answer. It's a community over on the Discord channel. So what that means is if you're going to post a question, look to answer somebody else's question. If you're in calculus, help somebody in pre-calculus. If you're in algebra 2, look to answer somebody else's question in algebra 1. And that's how that community is going to get stronger. And I want to make sure that students have a place where they can get their, questions answered in a timely manner, because I'm only going to be able to answer the questions, guys, every Sunday night. And again, I'm not going to get to every question either. So a lot of you have submitted questions, that I'm just not able to, get to every Sunday night. But I do have, I believe, 12 of them that I'm going to get to. And without talking anymore, let's go ahead and get on with it. So the first question is, what is a radian? The student was asking, I don't know, something about that. So I actually was kind of covering that this week, so I wanted to kind of discuss it. So let's go ahead and first talk about the other form of measurement is a degree. So again, remember an angle is going to be a rotation between two rays. And if we rotate these two rays, so like here's, there's the measurement of an angle, right? And if we take an angle and we rotate it all the way around, that's going to be 360 degrees. But a lot of students say, well, why is it 360 degrees, right? Why is it not 371 degrees, right? Well, 360 degrees is basically, without going into the whole history, we're going to say that is just the agreed upon measurement. It sections pretty nicely, into divides evenly fairly well. So we can use 360. And that's going to be measurement, obviously, like for 1 unit will be, your 1 degree, which would be 1/360th of a full revolution. But again, it's not very scientific, right? It's like you still answer the question like, what is a degree? Well, it's 1/360th of a full revolution. It's kind of, okay. So the next thing is I prefer, and a lot of other mathematicians just prefer the radian. And the better way to kind of answer a radian is if you think about, well, let's pretend here we have a circle. There we go. Beautiful circle. And the distance from the center to any point is called the radius, right? Now, again, think about the radius as a dried noodle. Okay, so if you had a dried noodle, there's the radius. You have that measurement. Now, if you take that dried noodle and you put it into hot boiling water, it's become malleable. And then you can wrap that radius around the circle. So the rotation of a ray here from this initial side to the length of the radius wrapped around the circle is going to be what we call 1 radian. Okay. And then if you take that radius and wrap around twice, that would be 2 radians. And then if you do it 3 times, that would be 3 radians. And again, it looks like it's almost 3 radians halfway around a circle, right? It looks like it's almost 3 radians, but it's just not there. So then we say, well, what is it? Like, how far is it? Well, it's 3.14159, ... And you can see that it's 3.14. Its pi radians is halfway around a circle. So that means all the way around the circle is going to be 2 pi. So 360 degrees is equal to 2 pi. Or we could say pi is equal to 180 degrees. Okay, so that's just the small little definition here of a radian to go for them. The next one example was provided by Hugga Baby Bear. Very nice name. You guys are allowed to do a shout out when you submit your things. A lot of people don't provide their name, so it's like whatever. But the student was asking me to solve this using substitution. So typically you're going to want to use substitution when you have a coefficient of 1 for any of your variables. In this case, you can see x has a variable of 1. So what I'm going to do is I'm going to isolate the variable by adding a 2y. So therefore I have x equals 2y plus 11. Okay, so again, x equals 2y plus 11. So that means I can substitute in the value of x for 2y plus 11. So I can do that into this top equation. So I could say -7. Instead of times x, I can now say times 2y plus 11. And then minus 2y equals -13. Okay, so substitution, this is the process of substituting in a value for an expression that is going to be equal to. So now we'll just go ahead and distribute. So this is a -14y minus 77. Minus 2y equals -13. Okay, and now we're just going to, clean this up a little bit. So this is a -16y minus 77 equals a -13. Add a 77. This is a -16y equals a 80. So that's going to be a 90. And then divide by -16y. Not -16y. What are you doing? Divide by -16. And 32, 64, 70, 80. Am I doing that right? Or did I make a mistake? Oh, I did make a mistake. That's not 70. That's not 70. That's going to be 60, right? Or that's a 64. Idiot. So that's going to be a, 64. There you go. Divide by negative 16y, so then y equals, that's going to be a negative 4. Anybody get it? Anybody get it? F. What are you guys doing? Hey, I'm for but I don't check my chat a lot, but I do check my chat when I see people that are spamming inside of there. So, guys, no need to be able to do that. I can see that in the left side of my eye. So, please do no need to spam the chat. Okay? Thank you. Yes, it is negative. So, that is going to be a negative 4. All right, and now that I know that y is equal to negative 4, I can plug in negative 4 in for here to solve for x. So I'll say x equals 2 times negative 4 plus 11. So it's going to be negative 8 plus 11 is going to be a positive 3. So x is equal to 3, y equals negative 4. You could write that as a solution point, 3 comma negative 4. And there you go. The next one is from Essenful as far as asking to simplify using the rules of exponents. I'm not really sure why the multiplication sign was used here, but that's okay. So a couple things. If we have a radical, we can just rewrite that as a rational power, okay? So we can rewrite this as a 3xy quantity squared, and then I can write this as a x to the 4th, y to the 6th to the 1/2 power divided by a 2x to the 4th y cubed squared. All right, so when I'm doing a rational expression for rules of exponents, what I always like to do is simplify the numerator, simplify the denominator, then go ahead and apply my either quotient properties. All right, so usually simplify the numerator, simplify the denominator, get rid of any negative powers, and then apply the quotient rule for my exponents. Now, in this case, to simplify my numerator and denominator, I'm going to need to apply the power to product rule. And the power to product rule basically states if you have x to the m times x to the n raised to the, a power, then that equals x to the ma times x to the na. So you can distribute this a to both powers, to everything that's inside of there. Or I guess you put it right in there. So anyways, in my numerator here, I'm going to have a 3 squared times x squared times y squared. And then this is going to be a power product. So you're going to multiply the 4 times 1/2. So this is x to the 4 times 1/2 and y to the 6 times 1/2. And that's going to be all over, let's see, that's a 2 squared, x to the 4 times 2, y cubed times 2. Whew. All right, so let's see what we get here. So that becomes a 9, x squared, y squared, x squared, and then y cubed. And this becomes 4, x to the 6th, and y to the 5th. Okay, and then you can simplify again, so we could rewrite this as a 9, x to the 4th, y to the 5th, over 4, x to the 6th, y to the 5th. Well, obviously, y to the 5th divided by y to the 5th, guys, is just going to be 1. Here, you could divide out the x to the 4, x to the 6. So we're going to get a final answer as you simplify this. You can't really do anything with the 9/4. So that's going to be 9. And be over, let's see, a 4 x squared, right? Because these x to the 4th over x to the 6th equals 1 over x squared. There you go. And y to the 5th divided by y to the 5th is obviously equal to 1. The next question, was that really 3? 2? Yeah. Okay. The next question says, could you explain parent graphs and how to solve absolute value equations and inequalities? That's a lot. But we'll kind of talk about let's talk about the parent graph of absolute value. So, y equals absolute value of x. Okay, so that is what we call the parent function. And the reason why I call it the parent function is because of the pure function without any operations. There's no transformation that is happening to the graph. And what's nice about this is we should know what this graph looks like. Okay, so it's over 1, up 1, over 1, up 1. And you can see that this graph is going up like this. Let me move that. So this graph is going up like that, and then this graph is going up like that. Okay, so you could create a table of values, and when we first learn the absolute value function, a lot of times will use just a table of values. But if you have to use a table of values to graph a function every single time, you'll realize it takes a long time. And it's not always going to be like as accurate, right? Because for a absolute value function and for a quadratic function, you got to know where the axis of symmetry is. You just can't randomly pick points. Like, how do you know which points to pick? So that's why understanding the transformations is very helpful, because if you know what the parent graph looks like, and then you know what the transformations are, like shift left, shift right, shift up, shift down, reflect x, y axis, reflect y axis, vertically stretch, vertically compress. You can apply those operations just to the parent graph, and then you'll get a sketch. And a lot of times, for a function, you only need to know a couple points to be able to graph the sketch. As long as you know what the graph looks like, you can apply those transformations to a couple points, and then you'll be able to recreate the equation, right? Obviously, if you want to be very detailed and very, perfect, then yeah, using a table of values is going to be very helpful, so you know exactly what those points are. But as I kind of mentioned in the beginning of the live stream, like, we don't need everybody to be exact. Like, if we want to be exact, we're going to use graphing technology, right? So I think just understanding the transformations and the parent functions is going to be useful and beneficial for most students. So that is how you kind of deal with the equations. As far as the how to graph absolute value equations, so I would just use the parent graph. So here's your equation: y equals a times, x minus c plus d. Okay, so a is going to be your vertical stretch or compression. I'm not going to include the b in this case just to keep things simple. C is going to be your horizontal shift left and right. D is going to be your vertical shift up and down. Now, so a is also a reflection about the x-axis as well as a vertical stretch or compression. So for instance, if we just had something like this, y equals a negative, let's just do this, a negative x plus 1 minus 2. Okay, so if we need to graph this, here's the parent graph. Let's just kind of go through the transformations. I'm not really worried about the vertical stretch or compression. I know that's confusing for a lot of students, but to be honest, I think you should just know what the transformations are, but don't really be worried about applying them for most situations. In here, we know the graph is being reflected about the x-axis, so it's going to face down. So here's your vertex. Now the graph is facing down, right? So it's pointing down. It's going to be shifted left 1, so the vertex is going to be moved over 1, and then down 2. And then from there, I'm just going to put the graph facing down. Okay, and there you go. There's an example of your point right there. Now, what about if it was an inequality? Well, if it was an inequality, you're going to do the exact same thing. So it'd be y is like less than or equal to negative x, or absolute value of x plus 1 minus 2. So whenever you have inequalities, all we simply want to do now is just use test points, okay? So we're going to graph the exact same thing like it's an equation. So negative 1 down 2, okay? And it's less than or equal to, so it's going to be a solid boundary line, right? If it was not equal to, then we'd use a dashed. Actually, let's just do that. Let's have a little fun. So it's less than, so therefore the boundary line cannot be true, so therefore we're going to use dashed. And then we're just going to test a point. So let's use 0, 0, because 0, 0 is the best test point to usually pick as long as the graph does not go through it. So what you're going to do is you're going to plug in test 0, 0 means you're going to plug in 0. Okay, so 0 plus 1 is 1. Absolute value of 1 is 1. Times negative 1 is a negative 1. Negative 1 minus 2 is going to be a negative 3. So 0 is less than negative 3. So is this true or false? And you can say that that's false, right? So since my test point is false, that means all values outside of this graph are going to be false. That means all values under the absolute value are going to be true. So if you were to extend those, you can see that that is going to be your true point. So whenever you have inequalities, graph it just like an equation, but then use a test point to be able to identify those areas, okay? Beat me to it. Thank you so much, my love. All right, so let's go ahead and get on to number 5. How can you tell if an equation has infinite solutions based on looking at it? And that's a good question because, if it has infinite solutions, you're going to get something like, 3 is equal to 3, or, when you go ahead and solve, or you're going to get, x is equal to x. So it's always going to be true no matter what the values are for x. It's always going to be true. So obviously, if I had like 3x plus 1 equals 3x plus 1, like when you go ahead and solve this, you're going to get, 1 is equal to 1. So, obviously always look to see that is the left side equal to the right side. And if you notice, like, a lot of the problems, and again, I'm thinking about this in terms of Algebra 1. I'm sorry if you were thinking about this in terms of something else, but that's immediately where my mind went, and you didn't provide any examples. So I'll just kind of go from there. But a lot of students come up with, or a lot of the problems that you'll see will just be kind of hidden. It'll look something like this, and then it'd be like, equals 3x, plus 1. And say, all right, now solve the equation, right? And so so it doesn't look like it's the same, but once you do a little simplifying, you say, oh, okay, now it is exactly going to be the same. So that's how I always just like look, just kind of like simplify it a little bit in your head and see if the left-hand side is going to be the same as the right-hand side. All right, this student says, I was having trouble finding the x of angles. I can figure out how the exact angle and stuff, like complementary and supplementary, I just find sort of difficult, if you could help. So I'm not sure if they were having trouble with the equations, or if it was just the understanding of complementary and supplementary. So I decided to take up on this question, but hopefully you guys can see how sometimes it can be confusing for me as far as, I don't know, does a student just have trouble with complementary supplementary, or do they want, like, they understand how to do that, but they have a problem when variables are involved. I don't know. So I decided to guess. I really do not like guessing, but I figured I'd just cover this anyways. So, typically, guys, whenever you have complementary, what I tell my students to do in geometry, whenever they see the word complementary, I just write plus 90. Because that reminds me, that means two angles add up to 90 degrees. If they're supplementary, that means plus 180 degrees. And they're just going to keep on doing that every single time they see those words. So therefore, it's going to be drilled into them that they remember that complementary angles add up to 90 and supplementary angles add up to 180, because it is very, very easy to switch them around and forget. So therefore, if I know that two angles here, these two angles add up to 90 degrees, that's 9 degrees because you can see the little box, then I can write an equation, right? I can say 2x plus 1 plus 43 degrees equals 90. And now I can just do some math to go ahead and solve. So I'll subtract 43. Actually, you know what? I don't know why I use the degree symbol. Make things even more kind of confusing. But now we can just go ahead and add these. So I can say 2x plus 44 equals 90. That's supposed to be a double 4. Okay, subtract 44. 2x equals 40. Oh, I hate when it does that. 46, divide by 2, x equals a 23. Okay, so x equals 23 is going to make those two equations, or two angles, complementary, meaning they'll add up to 90 degrees. These two angles make up a straight angle, and hopefully you recognize that a straight angle is supplementary, meaning they're going to add up to 180 degrees. These are also what we call a linear pair. Well, thank you very much, my love, for supporting me with your lovely super chat. And I like that little birdie. That's cool. Fist bump. Awesome. So I think that was your first super chat too as well. Congratulations. Now you can go on other people's stream and give them a super chat. It's awesome. So the next one is the 3x. So anyways, 3x plus 2x minus 15, these are going to add up to 180. So, because they're supplementary. So 3x plus 2x minus 15 equals 180 degrees. Okay, so therefore I get a 5x minus 15 equals 180 degrees. And you add 15 to both sides. So 5x is going to equal 195. And then we got to think, well, 5 is going to go into, 200. That's going to be 40 times. And so therefore, it looks like it's going to go to 139. That's going to be 39 times. So x is going to equal 39. And voila, there we go. So hopefully that was helpful, but I hate answering questions, when I'm just making guesses or assumptions on the student's part. But so the next one, and look at this. I did not plan this at all. I thought this was so awesome though. Look at my number 7 is their number 7. Isn't that awesome? All right. So the student says, prove the following trigonometric identities. And we actually don't cover logarithms and trigonometric identities in my class. So I was like, ooh, I've never seen something like that. But then I looked at it and I said, okay, I see it. So there's a couple things that are going on. Whenever you're with logarithms, you want to think using the properties of logarithms. And then, we also, when I see secant and tangent together in trigonometric identities, I immediately think the Pythagorean identities. So the first thing we're going to want to do is if I need to get rid of the logarithm, I'm going to want to raise this to the base e, or raise this with a base e. But to do that, I need to combine them. So to combine them, I'm going to use my rules of exponents. My properties of logarithms. And when I have a logarithm plus another logarithm, then I can combine those by multiplying those two arguments. So I can rewrite this as secant of y minus tangent of y equals 0. Okay. Now, to get rid of my logarithm, I can raise this to the base e on both sides. I can actually multiply this. I see this is a difference of two squares. So that now produces a secant squared of y minus a tangent squared of y equals 1. Now, is this equal to 1? Well, again, sine squared plus, got to have an angle. Sine squared of, let's just say, theta plus cosine squared of theta equals 1, right? That is the main Pythagorean identity you should all know. And if we need to get tangent, so sine divided by cosine, so if we divide by cosine squared of theta on everywhere, we'd have tangent squared of theta plus 1 equals secant squared of theta. There you go. And if you subtract a tangent squared, you get 1 equals a secant squared of theta minus tangent squared of theta. So therefore, 1 equals 1, and it has been identified. Next question says, how do you get the axis of symmetry of a quadratic function with a fraction like this? So their function is h of x equals 1/2 x squared plus x minus 10. So if we're just looking for the axis symmetry, let's see, axis symmetry is going to be x equals opposite of b divided by 2 times a, I believe, if I remember correctly. Opposite b divided by 2 times a. Yes. So then we're just going to plug in. So in this case, we have a is equal to 1/2 and b is equal to 1. So let's go ahead and plug it in. So I have negative 1 divided by 2 times 1/2. Well, 2 times 1/2 is 1. Divided by negative 1 is negative 1 divided by 1 is negative 1. So x equals negative 1. So don't be afraid of the fraction. It actually works out in your favor in this case. You could do the completing the square, but I think that would be a little bit too advanced for having to do that problem if you're just trying to find the axis of symmetry. All right, the next question is solve the following equation for the y-intercept form and identify the slope of the equation. All right, so first thing we're going to want to do here is distribute. And then again, if we're trying to put this in slope-intercept form, we're going to want to solve for y. So I'll have a y plus 1 equals a 3x minus 3. And then I'll subtract a 1. Y equals 3x minus 4. Okay? And then we want to identify the slope. So again, in slope-intercept form, y equals mx plus b. M is equal to the slope, and b is equal to the y-intercept. So in this case, my slope is 3, and the y-intercept is going to be, 0, negative 4. Something like that. There you go. Tolu, that's actually not their name, but Tolu was asking is find the distance between 2 points. So there's a couple ways you can do this. I think the first thing whenever you're trying to find the distance or whenever you're given like coordinate points, I think it's always helpful just to graph the points. Like just graph them. If anything else, just graph them. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, negative 1. So that's 12. Negative 1. And then this one is negative 12, 1. Oh, man, that stinks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Positive 1. Okay, so a couple ways we could do this. We could draw a triangle. Okay. And when you draw a right triangle, that's a right triangle, by the way. When you draw a right triangle, you can use the Pythagorean theorem, like a squared, b squared, and c, right? A squared plus b squared equals c squared. Most students can remember that. They remember the Pythagorean theorem, or they can remember the Pythagorean theorem. So you can just find this horizontal distance, right? So A in this case would be 24 plus B in this case would be 2, and that's going to equal c squared. Now, that point is negative 12, 1. Okay, so that is the one method. But what if you, like, I don't know, couldn't graph them? Or what if you had like the square root of 12? And so you needed something that's going to be a little bit more, but you were at least allowed a calculator. Well, in that case, what you could do is label your points like x1, y1, and x2, y2. And to find the distance, to find the horizontal distance, all you're simply going to do is do, x2 minus x1. And so that's a, so we'll square that. And then find the vertical distance, you would do y2 minus y1. And then you'd square that, right? And you'd add them just like a squared and b squared. And then again, you're not going to solve for c squared. You're going to solve for, your hypotenuse, which in this case we'll call d. So then you could also use what we call the distance formula. So either way, you can use the Pythagorean theorem. I like to visualize it and use Pythagorean theorem, but you also just might be able to use the distance formula. And either way, guys, you're going to get the same thing. Let's figure out. Let me just show you this works. It'd be negative 12 minus 12, quantity squared, plus 1 minus a negative 1. And you can see that's how I'm still getting the exact same answers. Right, so this is going to be a 24, or negative 24 squared, but it doesn't matter. Negative 24 squared or positive 24 squared, still getting the same answer, and this would be 2 squared. All right, so I don't know 24 squared. 576. So 576 plus 4 is 580. Square root of 580 is 24. So this looks like it's going to be approximately 24.08. Okay, and I'll just leave it off rounded, but obviously you could have a rounding error from on there, or different rounding values. So hopefully that at least helps you for 2 different approaches for that one. All right, the next one is use both a graphical and a numerical evidence to explain why the tangent line, which is the derivative, to the graph of f of x at x equals 0 does not exist. Okay, so we know the tangent line is not going to exist if a function is not continuous, right, at that value. It's not going to have a tangent line. So let's go ahead and graph it. So actually, well, if we want to show that it's not continuous, what we could say is, well, what about then, if it's continuous, then x squared minus 1 has to equal x plus 1. All right, so it has to be continuous at the value 0, right? So we could say 0 squared minus 1 has to equal 0 plus 1. Well, negative 1 does not equal 1. So you can see that, hey, it's not continuous. And if it's not continuous at the graph, it's not going to have a tangent line. Now let's go and look at the graphical approach. So again, knowing our parent graphs, kind of what we talked about here, this is going to be x squared minus 1. So it's a parabola, right? Shifted down 1. And this is only for x values that are less than 0. So open circle, graph looks something like this. This is going to be a linear graph with a raised up 1, and that's going to be greater than or equal to, and that's going to look something like that. Okay, but again, at 0, you guys can see that this is not a continuous function. You cannot, there's nothing you can, there's no 2 points that you can draw on a curve. Like when we teach the derivative from a curve, what we do is, you take these 2 points, and then you get closer and closer and closer and closer to this point. So therefore you can find this, find this tangent line at that point, right? We can't do that here. You can't find the tangent line at that point because we are not continuous. So therefore that's how we can show that. All right, and this next one is there a constant processor you're having trouble? Oh, that's my question. In the inverse, what it actually is the f inverse. So again, if I give you a function f of x equals 3x plus 1, and then I say what is f inverse of x? Or what it denotes, can you reduce it like we reduce it with multiplicative inverse? And I'm not really sure with that, but yeah, I guess, you can, yes, and why sine inverse isn't cosine. So again, if you think about the multiplicative inverse, multiplicative inverse takes you back to your identity element, right? So our identity element, the multiplicative identity element, if I remember my vocabulary correctly, is going to be, 1. That's going back to be our identity. So if I have 5 and I multiply that by 1/5, Like that undoes it. That takes us back to 1, which is our identity element. So the nice thing about the f function and its inverse, so again, this -1 just means the inverse. And the way that another way you can think about the inverse is that it's like the undoing function. It undoes what this function is. So if I have a function, let's think about this. So if I have fx equals 3x plus 1, okay? My identity element in this case is going to be x, right? That is my like pure identity element. Nothing has been applied to that element, right? But if you think about this, function f of x, what is being happening to this function? It's being multiplied by 3 and it's being added by 1. So the inverse function is going to undo the multiplication as well as undo the addition of 1. So what is the equation that undoes those things? Well, again, to find the inverse, we can replace fx with y, swap the x and the y coordinates, right? And then solve for y. So then you get x minus 1 equals 3y. Divide by 3, you know, and then you get x minus 1 over 3 equals y, or you could say f inverse of x equals x minus 1 over 3. Okay, so that is our inverse. So again, if we have our function, this is going to undo that function, right? So one of the ways that we prove that functions are inverses of each other is we check the composition. Like f of g of x has to equal g of, oops, what am I doing? G of f of x. And what does that mean? Well, when you plug a function into another function, if you apply a function and its undoing function onto itself, it's going to undo each other. And therefore, we're just going to be left with our identity element x. So watch what happens. Again, this means plugging in g of x into the f of x function. And this means plugging in my f of x function into my g of x function. Okay, so watch what happens. Oh, well, crap. Let's call this g of x because I used that notation. So let's call this g of x, the inverse. So if I plug g of x into my f of x, I get 3 times x, which is going to be my g of x, which is going to be x minus 1 over 3 plus 1. And that's going to equal f of x into g. So that'd be a 3x plus 1 minus 1 all over 3. Okay, now as I go ahead and simplify this, those divide out. I get x minus 1 plus 1. Here, those will add to there. I get a 3x divided by 3. And therefore, hopefully you can see that x is equal to x. And these are indeed inverses of each other. So your question on why is sine inverse isn't cosine? Because cosine doesn't undo sine. If you think about like plugging in a value into the, and it like another way to think about this of these two inverse functions is like, let's go ahead and graph this. So 3x plus 1. And then this one's not going to be as nice, but whatever. Then let's graph this function, y equals 1/3 x minus 1/3. Okay, so if I go and graph these, so we have plus 1 and then 1, 2, 3 over 1. There you go. It's going to look something like this. And then this one's going to look something like this. Up 1 over 3. So 1, 2, 3. It'll be something like that. I'm not going to be perfect. All right. I know that. But my point that I want to make with you guys is that if there's a point on this graph, so for instance, 1 is going to be 1, 4, right? Plug in 1, you get 4. And then the plug on this point is going to be 4 minus 1/3 is going to be 4, 1. So plug in a 4, that'd be 4/3 minus 1/3 is going to be 3/3, yeah. So this one works. It's just a little bit harder to see. But the other point is the understanding of this point 1, 4, 1, 4, 1, 2, 3 is there. And then guess what? 4, 1, 1, 2, 3, 4, 1. That point's right there, right? So what's important about this is, you know, the x and the y coordinates are swapped, right? So if I plug in x into this equation and get y, well, when I plug in this y in for the inverse function, I'm going to get back the other x. Like the x and y coordinates are swapped for a function and its inverse. And if you look at your understanding of a cosine and sine, without going a little bit more further into this, what you'll see is those functions are not, like when you look at the graphs and the input output, the table of those two functions are not, the coordinate points are not swapped. So the coordinate points, the domain and the domain and the range of a function and its inverses are swapped. They are opposites of each other, right? And that is not the same for, that is not true for sine and cosine. And that is not why they're not inverses, but that is showing you a reason why they are not inverses. So there you go, ladies and gentlemen. If you joined the party a little bit late, I do apologize. And I do apologize for all of you that answered or that you guys, submitted any questions inside the chat. I didn't get to everything. I just, basically for the last 30 minutes, I've been kind of going about doing my math problems and getting everything set. But I will be going live again next Sunday at 9 p.m. Eastern Standard Time. And you guys can always submit your questions in the chat, not in the chat, in the description of this live stream is my link to the Google form where you can go ahead and submit your questions. I'll try to do my best for you. And if you are looking for something a little bit more immediate, please feel free to go to the Discord channel for there. I'd like to thank all of my YouTube members for supporting my channel, and then all of you for supporting me as being subscribers and showing up for my live streams. I really do appreciate you guys. I hope you guys are having a great school year. It has been something very interesting so far. We just finished off our first quarter with you guys. Oh, thank you so much, Melinda. You didn't have to do this, but I really do appreciate. Thank you. And I really do appreciate all the questions that you have been helping out with there. I hope, I hope that even answering your questions or something like you probably will understand probably more than most people. Like you actually learn, I think, like seeing the other types of math. And I'm not sure, Melinda, where you're from, but like seeing the different types of questions and like that students pose on Discord, or even like what I get, like I'm not used to seeing some of these problems. Like you're so used to seeing the same types of problems based on the textbooks or where you live and where you're from. It's pretty cool kind of getting like different questions. You're like, oh, all the different maths that people are studying. It really does make you sharper as a student. And so I really do appreciate, you've been helping out with the Discord. But then also I know that you've been benefiting, from a lot of your explanations and seeing a lot of the different types of math. So I always recommend guys, as you are looking into the Discord or helping some other people out, like answer some questions for people, like, look at their work and see what you can provide. I know a lot of people, I get it all the time. People are like, oh, well, do these 20 questions. I'm like, no, I don't have time to do 20 questions or to show you everything step by step. But, even just providing people some tips, some hints, or maybe showing them in a step or explaining some concepts, can go a long way on people because, we've all had to go through the same path. We've all had different struggles along the way. And just the idea and the ability to be able to help people for some things that make sense to you now is very, very beneficial. And, I think we've all been to that point where we've been struggling. We didn't know what to turn to. And there's a lot of great websites, a lot of great places for you guys to find help. But I think it's always important to have a community, where you can rely on people and people can help each other out. But yeah, always be mindful though of, people are giving up their time and their energy to help you out. So make sure when you do have questions that you're very detailed and specific and, trying to really get the most out of the question rather than like, hey, here's my 30-point review. Can somebody do it all? It's like, that's not going to go very far. And unfortunately, you'll see some of those, responses just don't get answered because it's like people don't have time a lot of the times to be able to answer all of those. But it is always helpful to to just add in some chat, add in some context for people and get them helped out. So, all right, guys. Let's see, man, I was like, haven't even stretched my back at all. I'm moving. All right. Well, I think that is it for the chat. We're going in. Hi, Addie, Sergeant, Caven, Frankie, Melinda Becker, and Great Steak of Oklahoma. Well, awesome. And see you guys. I have a Private test tomorrow. Go and get it, Hockey. You got it. All right, guys. Well, I am all set for tonight. Then thank you so much, guys. I got school tomorrow, so I'm going to go ahead and get prepped for that. But thank you again, guys, for joining in. I will see you all next week. Cheers.